Okay, so in this video we have an example question: find the derivative d dx of tan inverse, and we need to give the answer in terms of x, and the method that we're going to use is going to involve implicit differentiation. So we'll begin first by writing y equals tan inverse of x. And now we need to remove the inverse, and we can do that by tanning both sides. So we get tan y equals x. And now that the inverse has been removed, we can actually now differentiate this implicitly. So on the left, if we differentiate tan y, we get sec squared y times dy dx. And that's the implicit differentiation. And on the right, when we differentiate x with respect to x, we get a 1. And now we can make dy dx a subject. So dy dx equals 1 over sec squared y. And we actually do have already the derivative. We've got dy dx, it's 1 over sec squared y. But the original question, it wants us to get it in terms of x. So we need to somehow remove this y. And the method for that will be there's several methods. One method we'll be using triangles. We're going to make a triangle out of this original, this one over here. So here we have tan y equals x, and let's make a triangle. The angle is a y, so that goes over here. And we know that tan, if we do SOHCAHTOA, tan is opposite over adjacent. So we can have x over 1, if I do an over 1 over there, and make a triangle with x over 1. So opposite is x, adjacent is 1, and we can use Pythagoras' theorem to get the diagonal side. That will be 1 plus x squared, all rooted. And now that we've got the triangle for tan y, we can get sec y. Now sec is 1 over cos, and cos is adjacent over hypotenuse, so sec will be hypotenuse over adjacent. So that will be h over a, which happens to be 1 plus x squared, all rooted, over 1. And therefore sec squared y will be this thing squared, which is 1 plus x squared over 1, but over 1 we can just ignore. That's 1 plus x squared. And now that we've got sec squared y, we can sub it in. I'll also replace the y with tan inverse. That was what we had here. Y was tan inverse x. So the final answer is d by dx of tan inverse is this 1 over sec squared y, but we're going to replace that with 1 plus x squared. So it's 1 over 1 plus x squared. And that's a derivative of tan inverse in terms of x.